Hi, I'm Savannah Jones, and today we're speaking with Jeff Robley, a Divisional Vice President of Technology at Press Tech in New Hampshire. Besides increased complexity and shapes, what else can you share about new products and additional and tighter performance requirements?
More recent applications for freeform optics are for augmented reality or mixed reality goggles, and that's pushing a lot of even crazier freeform shapes that need higher form accuracy. The surface quality and how you define a good optical performance has evolved over the years as well. And so we focus on surface finish, which you need for keeping down scattered light, and any optical surface can't be rough. It has to be an optical finish. So we focus on surface finish, and then normally form accuracy, so figure accuracy, how much peak to valley deviation it is from the ideal over the whole surface. But now we're getting, and also this comes into infrared optics too, we get performance requirements in terms of waviness. And so in terms of spatial frequencies on the surface, high spatial frequencies are roughness, low spatial frequencies are form error. Then we get this middle zone, mid-spatial frequencies, a lot of people call it, or waviness. And that's some of what we're focusing on now, and our new fast tool servo technology is particularly well suited to address some of the new waviness specifications on optics for augmented reality. Okay.
Jeff, while everything continues to evolve, from your experience, how has Precitech innovation, such as spindle and slide, helped customers to ensure they can consistently and routinely turn out high-quality components?
So the slides moving at low velocity or floating on a film of oil. The high-speed spindle is the highest heat source on the machine, and we have to worry about temperature thermal expansion is one of the biggest error sources we're trying to. So that has to be an air-bearing, supported bearing. And they all have direct linear motors or rotary motors. There's no mechanical content. So nothing wears as far as the mechanical components. It's just covers and things like that. And so we keep pushing to make the bearings stiffer, lower vibration to get better surface finish, and then a better accuracy. But it requires better positioning technology, measurement technology with the scales, as well as how you control the motors. And that the electronics for controlling motors and measuring position have improved a lot over the years. And another piece that's driven that is high-speed computing. In the early days when I started, you had to build your own computer because you couldn't buy a commercial one that had enough power to do what you needed. And so that's driven the cost way, way down, the new electronics in particular, and improve the accuracy. So we can have very, very high positioning resolution down into the picometer range, tens of picometers we're talking about. It's mind-boggling that we can position down at those levels, so yeah.
What about instances where the parts change in weight from run to run? How do the slides and spindles respond to changing loads?
Well, the dynamics of the slides, it's a whole system. It's a structural loop from the workpiece through the slides, through what's supporting the tool. Anything that affects that structural loop, and inertia changes will do that, will change the dynamics of it. And to get really high performance, we have to fine-tune the servo loops, controlling the position of each of the axes. And you change inertia, it'll change, anything has a natural frequency. If you have a really fine-tuned servo, you tune it with particular natural frequencies in mind. And if you have a lightly tuned servo, it doesn't matter so much, but you pay a penalty in poor surface finish and form error. And so we've been working on new technology to automatically detect changes in inertia and natural frequencies and adjust the servo gains to keep the same servo performance as you change the mass on the inertia on the slides or spindle.
Well, with that in mind, how does Precitech help those customers to rise to the challenges and overcome those complexities?
Oh, well, I also run the applications group here, and a very experienced team there in applications, and had faced a lot of machining challenges over the years. And they remain available to assist customers in unique applications. We develop a lot of software. We have one called DIFSys. It's a computer-aided manufacturing software where we can go right from an optical design file and create a tool path that will run on our machines and try to simplify the process as much as possible, going from a design to a finished optic as smoothly as possible. And we continue to work on that. We've added more ease of use features on our controller since we do our own control system. Machine monitoring, we've got a whole wealth of machine diagnostic tools that I think are unique to the industry that give feedback to the operator what's going on with the machine in the process. If they've got a dull tool or something's abnormal, it'll flag that and tell them. So we're always trying to be able to allow customers to create better and better quality optics with lower and lower skilled operators. That's sort of the dynamic, you know, 'cause a real skilled operator can get a lot out of even a poor quality machine. So
So do your customers enjoy peace of mind thanks to Precitech products and the reliability?
I'll give you an example. We measure the outer straightness of all of our slides. And as being an oil-bearing slideway, the slides are made out of Durabar, and, you know, a high form of cast iron on a granite base. Is very, very stable. It doesn't change with time. So this outer straightness, which we'll go back maybe years later and recheck to see if anything's changed, and almost invariably is within 25 nanometers, 50 nanometers of the errors that it had previously. And so we make all the slide components, particularly the spindles, very robust. In case you do have an accident, everyone has an accident where the tool crashes into the machine. The machine can be quite robust against that, and because we build our own spindles here too, we can repair them readily if something happens, like they lost air pressure or get the spindle contaminated from poor dirty air, for instance. We can turn that around very quickly often in less than a week's time to keep the customer's machine time down. We have also, of course, monitors. For instance, if there's a loss of air, we have a tank on the machine that will keep the spindle running until it has time to stop, just self-contained in the machine. So you can cut the air line and still not cause permanent damage to the machine, as an example. Those are some of the things. You know, got a lot of safety interlocks as well.
Jeff, how else does that instill confidence that your machines achieve the level of performance that your customers expect?
Well, we do have some features on our machine where we can do on-tool process control, where we can actually do some levels of inspection of the machine, some of the part on the machine while it's still on the machine, to give some immediate feedback if something's gone wrong, like, for instance, a worn tool or a damaged diamond tool. It's nothing to do with the machine, but it can affect the quality of the part. You can detect that early on and just change the tool out and recut again with minimal lost time. We have on-machine optical inspection devices we can put on the machine, inspect optics right on the machine as well. We have a whole range of, I was telling you already, machine monitoring, looking at fouling errors, vibration levels, and while the machine is cutting and running, fast Fourier transforms, looking for vibration levels on the machine. Someone even slammed the door, or you had somebody drop something heavy in the next room, that can couple through. We can detect that in the fouling error of the machine, and we can flag the operator that something happened.
Well, we started out discussing diamond turning, and I'd like to revisit that before we wrap it up. Minimizing the sensitivity to vibration is really important for a diamond turning machine. How does Precitech do this?
As I spoke earlier, the key magic of diamond turning, it's a very deterministic process, we call it. So wherever the diamond is placed with respect to the surface, that's where the surface is created, because it's a very sharp cutting edge, low coefficient of friction. The metal cuts very cleanly and smoothly with the diamond tool. And so that means that whatever vibration level is on the machine, the diamond will work like an inverse record player, if you remember records from ages ago. Any vibration level, either the workpiece vibrating or the tool vibrating, will create a surface texture corresponding to that vibration. And that mainly affects surface finish. And that's been the biggest trend, I would say, over the last 20, 30 years, is the improvement in surface finish. And that's all tied down to better servo control and better control of vibration levels on the machine. And so these days it's pretty common. We can get fouling errors on the order of a nanometer. And this can drive surface finishes down as low as 0.2 to 0.4 nanometers RMS. I never dreamed you could achieve those kind of surface finishes in diamond turning when I first started my career. And some of that's related to stiffer components, the oil and air bearings, tighter, better servo loops. But fundamentally, there's always some vibration sources, either on the machine, fans and other things. We try to remove and get off the machine. But the dominant source left over is vibration that's coupled in through the ground. And a real critical element is how to isolate the machine as best as possible from the ground vibration. And that's where we work with our sister company. So part of our same business unit in Amatec is TMC, based in Peabody, Massachusetts. And they're world leaders in vibration isolation technology. And it's an interaction between the isolation and the frame and support design of the machine. And they're also experts on weldments and much more expert on how to build structures that sit well on their isolators and mate well with their isolators to minimize how ground vibration gets through to the critical part of the machine where the diamond tool and the workpiece are. So there's a whole range of vibration isolators, pneumatic isolators. They make active ones with piezo, active leveling with special valves to help control and cancel vibration. They'll even have vibration cancellation platforms like noise cancellation headsets that can be employed. And how they're integrated with the structure support of the machine is critical too. And then working directly with the engineers at TMC, we can get an optimized performance. And that's really helped drive down the vibration levels on the machine and helped us get to these new levels of surface finish.
Jeff, you are a wealth of information and knowledge and been in this field for a long time. What keeps you interested in the industry and in Precitech? I've
been in this industry now for 45 years, I can't believe it. And I still learn something new every day. And it's part of the discipline of precision engineering, which is bringing in a lot of engineering disciplines. You have to be really good at mechanical engineering, materials, electronics, electrical engineering, servo controls, and you have to bring this together as a system to get working together. So you have all these different challenges in all these different areas, and if you make improvements in one area, that error source goes down, then another one becomes the dominant one, and every day it's a new challenge, and I learn something new every day, and it's just, I'm still intrigued with this. After 45 years being in this field, I'm still challenged every day and learn new things every day, and it's kind of amazing, because it's at that level where everything's important, it's not dominated by one or two error sources, but so that just interacting with all these different specialists and bringing all these technologies together to get a strong functioning system in the end. That's real exciting for me from a technology perspective, and keeps me going and why I like working here. I agree. Always learning is a great way to live and enjoy your life. Jeff, before we go, what would you say to someone who wants to be a part of Precitech? If you want to be challenged and have something interesting and different to do every day, and interact with people, experts in a lot of different fields, bringing technologies together, and then working with satisfied customers. There's lots of challenges working with service and applications, customers in the field. People are coming up with new uses of our machines every day, really. And I get demands for that, and we try to figure out how to respond to them. And so it's never boring. Jeff, thank you so much for your time and your insight on Precitech. I appreciate it.